This is the video lesson for vectors versus scalars. The learning target for this lesson is, I am learning to define vectors and scalars by recognizing their characteristics. The success criteria for this lesson are, I can define scalars, I can define vectors based on their two parts, and I can write vectors in equations and draw them graphically. So what exactly are scalars? What does this word mean, scalars? So a scalar is a number as we've always known them. So numbers as we've always known them up until this point in our lives. So up until you've taken physics, scalar is what we think of as numbers. So we can also think of a scalar as being a number with only magnitude. So it's only a size. So think about the temperature. So 100 degrees. That is a good example of a scalar. All right, so we've defined a scalar. So what about a vector? What exactly is a vector? So a vector is a number with two pieces of information built into it. So we have two pieces of info built into a vector. So what are these two pieces of information? So we have a magnitude. So this is the size of the number. And remember, we said that a scalar only has magnitude. So we can think of the magnitude of a vector as being the scalar part of the vector. And then the second part of a vector is the direction. So what direction is the thing moving in, or what direction is it pointing in? That is the second part of the vector. All right, if you've ever seen the movie Despicable Me, there's the character Vector who can explain for himself why he uses the name Vector.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So if you ever forget what a vector is, what two parts make up a vector, just think about Vector from Despicable Me, who's committing crimes with both magnitude and direction. All right, let's look at how we write vectors and how we draw vectors. Okay, so using vectors with variables in an equation. So if we have a v for velocity, to denote that it's a vector, we draw a little arrow above the v. That lets everybody know when we're looking at it that it is a vector. Same thing if we had an a for acceleration, draw a little arrow above it. That means that it is a vector. Or f for force. Force is a vector. So we draw a little arrow above it, and that lets everybody know that's looking at it that it is a vector. And then if we wanted to draw a vector, so drawing vectors graphically, we have an arrow. So that we would be drawing a vector graphically. It has the length of the arrow, so how long the arrow is. This length, L, let's call it, is the magnitude of the vector. And the direction that the vector is pointing in, so whatever direction it's in, is its direction. And we think about direction in lots of different ways. We can think about the angle that the arrow makes, so whatever angle that is, or the direction, say, this is kind of like northeast, so northeast. We can think about the direction in lots of different ways, but when we're drawing vectors graphically, the length of the arrow is the magnitude, and the direction the arrow is pointing is the direction. All right, let's talk about some examples of vectors and scalars. So examples of vectors include velocity, as we talked about earlier, acceleration, also talked about earlier, magnetic fields are also vectors. So lots of different kinds of fields are vectors. So if we had a magnet here with a north pole and a south pole, we have the magnetic field lines coming out of the north pole and going into the south pole. The magnetic field lines have direction. They go from north to south, and they have a magnitude. The strength of the field is implied in the vector. So, and there are lots of others which you can think about and try and come up with some. And then we have scalars. So let's look at some examples of scalars here. So anything that has a magnitude but doesn't have a direction. So speed as opposed to velocity. So speed is the scalar of velocity. So it's the scalar of velocity. So it's the magnitude of velocity. It doesn't have direction. It just has the magnitude. Temperature is another example of a scalar. There's no directionality to temperature. It's just, let's say, 40 degrees Celsius or minus 10 degrees Fahrenheit. There's no directionality. Altitude is another example. It's 30,000 feet. Or it's 10 kilometers high. And then there's lots of other examples of scalars. See if you can come up with a few. All right, everybody, keep asking questions. It's how you learn new things.